Hi, Deirdre Macnamara here from Letterkenny IT, and in this set of slides we're going to take a look at the components of computers and really this sort of IT or information technology theory. We're going to break down the IT theory into two main areas. We're going to look at hardware and software. So hardware refers to the physical parts of a computer, those parts which you can see or you can touch, the physical things like the keyboard and the mouse and the box unit and the screen, etc. The software, primarily a list of instructions coded in a special way that computers can understand. So it's the set of instructions that actually run all the hardware, and that's what software is, and we'll have a look at that in more detail. So hardware. We're going to take a look at an ad for a computer. We'll look at data measurement, how we look at that, look at the different types of computers. Processor, what is it? What's it made up of? We'll look at memory. We'll take a look at things that determine the speed of the computer. We'll look at input and output devices. And we'll take a look at storage as well and ports. Okay, here is an ad that was displayed on the 16th of November 2016. It's from Curry's PC World. And we're going to take a look at the details of things that make up this ad. So this ad here was €449, which is a reasonable price. And they have said, happens to be a HP ad. We just randomly picked an ad here and thought we'd take a look in details at this. So the details it's giving us is it's a 15.6-inch laptop. It's an everyday all-rounder for work and play, Windows 10. It's talking about the AMD, which is a type of processor. It's the memory it's giving you, how much space is available on the hard drive, what the graphics are and the graphics processor, and what the battery life is. Okay, and you can see it's on discount at the moment, and we're trying to take a look and see, is this a good computer or is this not? Who would this be suitable for, and what sort of person this might be appropriate. Okay, so here is an example of some technical specifications. Paraphrased from the online electronics retailer that we just saw previously. Okay, so a 3.5 gigahertz AMD Generation 9 processor, and 8 gigabytes of RAM offering superior power and speed for gaming, entertainment, photo editing and multitasking. Okay, 1 terabyte, 5,400 revs per minute hard drive gives you plenty of space for documents, movies, videos and pictures. It says it's got 2 USB 3 ports enabling for very fast transfer speeds with USB 3 devices, and it's got 1 HDMI output that lets you watch games and movies on the big screen, so you can connect the laptop through to a television, etc. Okay, so looking at units of measurement and specifically looking at large units of measurement, for example here we've got 3.5 gigahertz. Okay, G usually means giga and HZ is hertz, or how fast the thing spins. Okay, so looking specifically in your data measurement chart here, we've got the data measurement here is a bit. And what is a bit? A bit is a 1 or a 0. And in a fundamental sense, this is how everything is stored on your computer. So everything is stored as either a 1 or a 0, and it may take a number of 1s and 0s together to represent, for example, a letter. So these 1s and 0s are often stored in terms of magnetism being on and off, in terms of there being a mark or not a mark, and there's a number of ways that these 1s and 0s can be stored. Okay, so a byte then is a combination of 8 of these bits put together. So 8 bits together make up a byte. Okay, a kilobyte is 2 to the power of 10, okay, or 1,024 bytes. Okay, a megabyte is 2 to the power of 20, or 1,024 kilobytes. Okay, so roughly 1,000 of the previous items. A gigabyte is roughly 1,000 megabytes, or 2 to the power of 30. A terabyte is roughly 1,000 gigabytes. A petabyte is roughly 1,000 terabytes. And an exabyte is roughly 1,000 petabytes. Okay, so they're increasing by a factor of 1,000 each time. On the computer, all information is stored in binary, 2 states, for example, on or off. And again, as I've mentioned previously, this could be pitted surfaces or versus a smooth surface, connected via disconnected in terms of circuitry. A single on and off, on or off, is referred to as a bit or a binary digit. Okay, so that might mean off, and then this is on. Okay, so that would be a single bit, and that's it, off, or it could be on. 8 bits together are referred to as a byte. So for example, this would be a single byte. The amount of information that can be stored and transferred is typically measured in bytes rather than bits. And we've gone through each of those. Okay, so again, just to get a visual representation of what we've been talking about, a kilobyte, okay, is 1,000 of these. Okay, 1,000 bytes altogether. Okay, so just to get an idea of what that might store, a low quality preview or a thumbnail image that you might see in Google Images, etc., may range in size from a few thousand to tens of thousand bytes in size. So a megabyte or a million bytes, okay, so again, this is a byte here, and a byte can be used to store, for example, the letter A. A megabyte is roughly 1 million of those. So a typical image may range in size from 20,000 bytes to several million bytes. Okay, audio files, MP3 files are several megabytes in size. So streaming internet video or compressed can be several hundreds of megabytes for a full movie. So looking then at a gigabyte, which is roughly 1 billion bytes. Okay, 1 billion letters A. Several hundred camera images or audio files. 30 minutes of DVD can be held in a gigabyte. So it's about a quarter of the information that can be stored on a standard DVD. So a terabyte is 1 trillion bytes. Okay, so again, just looking here, it's 1 trillion letters can be stored. So several 100,000 images or audio files or 200 DVDs can be stored in a terabyte. Or if you the higher quality image, so for example Blu-ray, roughly 32 Blu-ray videos. Okay, so here's a screenshot from somebody's hard drive of images, and you can see there's different image types. We've got the BMP image type or the JPEG image types, which you might have seen from your cameras. And here's the different file sizes relating to those, and that's kilobytes. So 24,685 kilobytes for this single image. Audio file sizes, over here we can see, okay, this is 3 minutes and that's 4.9, roughly 5 megabytes for. So video file sizes, the lengths of the videos range from 30 seconds to 45 minutes in the next screen that we're about to show here. Here are different images ranging in size from roughly 5,000 kilobytes up to 133,000 kilobytes. Okay, let's take a look at different types of computers. We've got our mainframe computers, which are those very large computers used by banks and governments to run very large operations. You've got networked computers, which have very little intelligence locally and rely on cloud-based resources. You've got PCs, we've got desktops, and we've got towers, we've got laptops and notebooks, handheld computers, mobile phones. The gap between computers and mobile phones is rapidly decreasing, and really the intelligence on some of the new phones would match some of the laptops and notebooks, or maybe even be larger. You've got your set-top boxes, which people are using to access the internet as well, and the gap between these and PCs is rapidly decreasing. So which type of computer is for you? There's no single model, let alone manufacturer, that is best for everyone. So it depends on what you're doing as to which computer will be best for you. So what you need to ask yourself is, how will you use the machine, and what things are most important for you? Is portability important? Do you need to be able to move it about? Do you need touch screen? Okay, do you actually need that? Will it be used? Will you run programs that will push your system? So for example, if you do a lot of video editing, or if you do a lot of gaming, then you probably will need a higher spec machine. Image and 3D graphic editing is also needs high resources. Or are you going to use it for sort of fairly normal, low resource intensive tasks, like typing a few letters or doing a little bit of surfing on the internet? Okay, so depending on what you're doing, you need to choose a different computer. Is gaming in general, even ones that don't really push your system, important? And if so, you might need a higher spec machine. You also need to take a look at not only what you need now, but also future expandability. Will you need to do extra things in the future, and will you need to be able to expand your machine later on? Tablets. They're the lightest and they're most portable. They have a touch interface, so there's no keyboard generally with tablets, and that's really useful. They don't have a clumsy keyboard, which is nice, and they're very easy and handy to use, but it can get quite annoying if you're trying to do a lot of text input and by mistake you're tapping on the wrong thing. So they're extremely good for light work, but on the bad side, often you're not getting the best value for money in terms of the performance you're receiving. Laptops and notebooks. Compared to tablets, they have a larger display area. Generally, they have CDs and DVDs, as well as a physical keyboard, and they may or may not have a touchscreen capability. So 2-in-1 laptops combine the power of a laptop and the portability of a tablet, so you can actually take off the keyboard aspect of the laptop. But compared with desktops, they're a lot more portable. But again, in the price performance that you receive in a laptop can often be of lower value than a PC. And often the choice of hardware is not as good for a laptop as it is for a PC or desktop machine. You can have specialized and variant laptops. You can have ultrabooks, which are extremely thin and very, very light, but again are not providing you with the highest value for money. You've got netbooks, cheaper forms of laptop, and again they don't have a lot of intelligence locally, and you're relying on cloud-based resources. Some common features on regular laptops are excluded, so things like CD drives, etc. So if you want to take a look, here's some interesting links that you can click on. Hit pause and you can click on those links. Desktop computers. Okay, everything is separate. So your computer is separate from your monitor, is separate from your keyboard. And the advantage of that is, if anything goes wrong, you can just replace that one aspect of the computer. The disadvantage is that they have a larger footprint, so they take up more space. An advantage then is that it's easier to expand these items. You can add in one extra little piece to it. And compared to portable laptops and tablets, the cost can often be cheaper when you're buying a desktop computer. and they have improved in terms of aesthetics. Okay, and you can see down here we've got an example of that. You can have all-in-one computers, okay? Although technically this includes tablets, it's kind of a unique category of computer, okay? So in this case, the screen and the intelligence and the computer and the storage is all held kind of in behind the screen, a bit similar to the Apple. And over here you've got a classic example of that. It's commonly chosen when a desktop is desired, but space is very limited, or some portability is desired. This is somewhere in the middle between desktops and laptops, and it balances portability and the hardware capabilities and power. Okay, central processing unit. This is the main brain of the computer, and it is made up of the control unit and the ALU, or the arithmetic logic unit. Okay, so the control unit fetches instructions from the computer's memory, it decodes them and synchronizes the computer's operations. So it's the organizer or the administrative part of the central processing unit. The arithmetic logic unit, or the ALU, is where all the maths and intelligence goes on. So the control unit feeds the ALU with tasks. It feeds it with maths, and it feeds it with additions and subtractions. And in reality, the only intelligence going on your computer is additions and subtractions, and the control unit feeds the ALU with these tasks. The speed of the central processing unit is measured in megahertz or gigahertz. Okay, hit pause and watch this YouTube video here on the central processing unit. And when you're ready, move on to the next slide. Okay, so looking at the benefits of having a faster CPU, well, the programs are loaded faster. So when you're starting up something, it'll start up faster. Viewing videos and gaming and game playing on your computer may be faster and free of glitches. And calculations are completed more quickly. Evaluating, for example, the results of a spreadsheet in Microsoft Excel. Okay, the CPU clock speed. Aside from the processor model, it's the most common technical specification of Okay, multi-core processors. Not to be confused with the model name of some of the Intel processors. For example, they talk about the Core i3 or the i5 or the i7, the Core i7. Okay, so basically how many things can go on at one point in time. AMD also and other manufacturers also have multi-core processors, and it's really how many things can be run at this exactly same time. The number of cores determines how many tasks that a computer can execute at the same time. So I'm going to show you here now how a single core computer works. They only appear to work on multiple things at the same time or simultaneously. So here's an example. You have your machine on and you start doing some video editing, okay? And it's processing and it's taking a few minutes to do the video editing, and you decide to go off and maybe do some video gaming. So it's running the video editing. It'll pause now the video editing, and you'll start playing the video game. So both of them actually don't run at the same time. As a user, you won't really know this, but actually the processor in a single core processor, only one item can be handled at a time. So it does one, stops doing that, waits a few seconds, and then does the next one, pauses, and goes back to the original. Okay, so it divides up the time equally between the two tasks going on. Now, multi-core processors, or dual core or quad core as we look at later on, can actually work on two things at exactly the same time. So they don't pause one as they do the other, they do the two of them at exactly the same time. So you've got your computer on, and at exactly the same time it's doing the video editing, for example, on one of the cores, and it's playing a video game on the other, and they're both happening at exactly the same time. other multi-core processors. You've got quad cores, 6 cores, 8 cores, and there's more information about quad core processors here. So again, when you're looking at speeds, you also have to take into account not only the speed that each of the cores go at, but also how many cores are involved. Having a processor with multiple cores can speed up execution time, even if only a single hardware intensive program that's pushing the computer is running. The program are often written specifically to take advantage of multi-core technology. So new bits of software are being designed to run on multiple cores at the same time. You need to check the system requirements or the technical requirements on the packaging of the software. So for example, Photoshop and Excel and Crysis, which is a shooter game by EA, will take advantage of multiple cores running. So for example, the first core runs one part of the game and the second core runs a different part of the game at the same time. So another important thing to take into account is the model of processor that you're looking at, and this will often determine the speed of execution as well. So in terms of Intel, the Pentium and Celeron are the bargain basement ones. They're very old, low-end chips at this stage, and unless you're really stuck for cash, generally you should avoid these processors. The Core i3 is, an entry-level machine. It's a dual-core processor, so there's 2 cores in this. Good for budget computers, for basic everyday computing, if you're just doing a little bit of word processing and web browsing. But if you're doing a lot of video editing or playing video games, then maybe the i3 isn't the one to go for. Okay, the i5 is good for most tasks or most users. Mainstream quad core, that's 4 cores, and it's on a handful of the lower end. A handful of the lower end i5s are actually dual core, so you need to make sure which version of the i5 you're getting. It's common in many desktop models or some of the all-in-one computers. The i7 at the moment, and this is 2017, is for high-end powerful computers or for hardware-intensive tasks such as games, video editing, etc. And here's some links if you want some additional information. AMD is another processor manufacturer. They tend to be a little bit cheaper for the amount of speed you get, but a lot of people don't feel they're as good as the Intel processors. Here's some information if you want to take a look more closely at these. But my recommendation to you is just before you purchase a machine and you're looking at 2 models, go online and get a comparison of the processors that you're looking at to see which is better. Computer memory. Hit pause now on your on the video and just watch this video here. There's a link in it, and click the link and watch the video and then return to this video again. Okay, so there are 2 main types of memory. You've got random access memory and you've got read-only memory. The main one you're interested in is the random access memory, or RAM. This is the computer's working memory, and often the more RAM you have installed, the faster your computer will work, and the more things you can run at once. Read-only memory is used to start your computer and load Windows, and ROM can be accessed only by the CPU or the central processing unit, and you can't change it. So you're not really that interested in ROM. ROM isn't really a significant feature that you need to watch out for when you're buying a computer. So RAM. When a computer program is executed, the instructions as well as any data currently needed, for example images or videos, is loaded into RAM from the storage device, which is usually your hard drive. So RAM is a temporary storage, which means it's gone, or it's volatile. It's gone when you shut off or restart your computer. It's really, really fast, but because it's volatile, you lose the information, and you need to have another place that you're going to store things as well. So it's faster than any other storage device on your machine. The other aspect of RAM is that it's more expensive on a per unit or per gigabyte basis than your hard disk will be, or any other storage device would be. And that's why generally the amount of RAM you're going to have on your computer will be a lot smaller than the hard drive, etc. So it's really, really fast, but it's expensive per unit. And the other disadvantage is that when there's no power, all of the information is lost. The memory capacity of today's computers are typically specified in either single or double-digit gigabytes. So gigabytes is generally how you measure RAM. And if you recall, that's billions of bytes or billions of letters that can be stored in RAM. So how much RAM would you need if you're buying a machine? So 4 gigabytes, if you purchase something with 4 gigabytes, that would be okay for doing basic web browsing, a little bit of email, word processing, sort of the basics of a computer. If you're up at 8 gigabytes, this is multitasking. You might be running a few things at the same time simultaneously, playing simple or lower end video games, watching regular definition movies, simple photo editing, etc. 8 gigabytes would be perfect for that. 10 gigabytes and above, this is when you're doing multitasking and you're using very hardware intensive applications such as games with higher resolution graphics. So as a rule of thumb, the first-person shooter and 3D games rather than simpler adventure role-playing strategy games. Video editing, 3D or extensive image editing, sort of Photoshop, HD definition entertainment, etc. You're going to need 10 gigabytes or above. This is 2017. Okay, and the ad that we were looking at originally was 8 gigabytes of RAM, so that's in this category here. Regular multitasking, regular usage. Okay, computer performance and what affects it. Well, the first thing that will affect it is the speed, and we've talked about that, the speed of the processor or the CPU. The amount of memory you have will determine how fast it'll go. And the next thing is how many things you're trying to do at once. If you're only doing one thing, then the processor can focus on that and the memory can focus on that. But if you're running 2 or 3 things at the same time, then the speed of the processor and the amount of space and memory is used up by the multiple applications that you're running at the same time. Another important factor is the amount of free space that's on your hard disk. So you need to make sure that there's a certain amount of free space on your machine that you can use to help run the machine. And another factor, especially for loading up new applications or for saving files, is the speed of your hard disk. So how fast your hard disk spins at or is able to record at will determine the overall performance of your machine. Okay, looking specifically at input devices then, these are things that put information into the machine. So the main one then would be your keyboard, it would be the main input device, mouse, trackball, microphone, pens, scanners, cameras, etc. Output devices, the main one then would be their screen. That's where you see most of the information that's going on in your computer. They come in many sizes. Pictures made up of dots called pixels. The picture quality depends on the number of pixels going across and down the screen. So again, the quality is determined by the quantity of pixels on the screen, and it's also determined by the refresh rate, which is the number of times the picture is drawn on the screen and whether you'll have a sort of a flicker on it. Hit pause now in the video and you can watch this video down here to see the different types of screens that are available. Okay, but the main ones that are available, plasma, which are generally not used for computers because the image will burn onto it, and you've got LED and LCD screens. But take a look at the video. Okay, so looking at resolutions then, you've got 800 by 600, which is typical for like a 15-inch screen, and higher resolutions if you're projecting onto a larger screen or a projector is 1600 by 1200. Okay, printers. The most common sort of household printer would be the inkjet printer, and the great thing about it is that you can do both black and white and colour printing, and the ink is forced through holes onto paper, and there's a little ink is sort of squirted at the paper in little tiny dots on the screen. it's very, very cheap to purchase an inkjet printer, but the running costs, or the cost per page, can end up being quite high. One thing to be aware of is once you've opened an ink cartridge, it will dry up within 6 months, regardless of whether you use it or not. So don't be too miserly with the ink cartridge. If you don't use it within 6 months, it'll already have dried up and you won't get to use it after that. So laser printers would be the most common one in a business environment. They're very high quality printing, usually very quickly. They're suitable for large volume printouts. And while laser printers are more expensive to purchase, the cost per sheet of paper is a lot lower than your inkjet printers. So inkjet printers are cheap to buy but more expensive to run per page, whereas laser printers are more expensive to buy but cheaper per page to run. You've got dot matrix printers. They're very much gone out at this stage, but they are still used in, for example, hardware shops, or if somebody needs to print in triplicate as well. They can be very noisy, and they do their printing by actually tapping little pins against the paper, and that's why it makes a noise. You've got plotters, which are used for architects, sort of very large scale printings, larger than A3. Speakers, again, another way of getting information out of the machine. They're connected to a sound card, which is supplied with most regular machines. The quality of the sound produced can either be controlled on the speakers or from within the software. Now, some laptops won't have very good quality speakers because the laptops have become very thin, and it's hard to make a good speaker in a very thin shape. So projectors, again, another way of getting information out of your machine. Headphones, which you might be using right now to watch this video. Storage devices. These are needed to store data on your computer. Some of the older technologies will be things like CDs and DVDs, USB sticks. You have tape, which were used for creating backups. You've got internal and external hard drives, and also now you can have cloud-based drives or network drives as a place of storing your information. Hit pause now on your video and click the link here for the video. All data that's needed in the long term must be kept in some form of storage device. So the storage, the hard drive, something that may not currently be needed but is needed at some point in the future. Okay, and memory is something that is currently used and must be stored here. So remember, the difference between RAM and regular storage is RAM is really, really fast, and it's very closely linked to the CPU. It's usually physically located beside the CPU. So it's really fast, it's expensive per gigabyte, and also when there's no power, RAM loses its information. Your hard drive or other storage device is usually physically located further from the CPU. It is cheap per gigabyte, but unfortunately it's slower than RAM. Okay, so it's cheap. And the other advantage of the hard drive is that hard drives will hold the information even when there is no power. Okay, so they're not volatile. Okay, memory is volatile, so when there's no power, there's no information stored in it. Looking at different types of hard drives, the two main types of hard drives are magnetic hard drives, which are the traditional ones that are in the vast majority of PCs and laptops at the moment, and the new solid state hard drives. Now, the magnetic hard drives are literally disks that spin around at very high speeds, and they use magnetism to store their information, whereas solid state hard drives have no moving parts, and so are thought that in the future they will prove to be much more reliable. The typical storage capacity of hard drives is measured in gigabytes or terabytes, or single digit terabytes at this point. Okay, hit pause now and take a look at the video of the comparison of hard drive types. So a magnetic hard drive, 1 terabyte on amazon.co.uk is €70. They're slower, but they're cheaper. Hard drives with the highest capacities are generally only magnetic and less durable. Okay, in other words, there's moving parts in this, there's magnetic fields, temperatures may affect these magnetic hard drives. Solid state hard drives, 1 terabyte in the same shop, amazon.co.uk, is 210. So you can see dramatically more expensive. They're faster, roughly double the speed of the magnetic hard drives, more expensive, so as we've mentioned, lower maximum storage capacity, so you can go higher on the magnetic side than 1 terabyte, but on the solid state it's harder to go to the very high capacities. They're generally thought to be more durable, but they're still in their early stages, so I'm not 100% sure that in 2017 that's necessarily true. This video looks at the amount of capacity a hard drive has over here on the left hand side. So over here it's the capacity of the hard drive, and here are the number of images that for example a 256 gigabyte hard drive could hold 256,000 images of about 1 megabyte per image. Songs that are about 10 megabytes per song, 25,000 of those. Movies, approximately 70 megabytes per hour. And 3,657 hard HD movies, so that's roughly 2.4 gigabytes per hour. That's 107 of those. So again, it's just showing you the relative capacities of each of the hard disk capacities over here on the left, and the amount that those capacities can store in terms of images or songs or regular movies or HD movies. So in the advertisement we looked at, it was a 1 terabyte hard drive, which is a relatively large capacity and can hold quite. Remember, it's not all free, so formatting a hard drive uses up some of its capacity, so you don't actually have all of the space to play with when you're saving information. Different operating systems take up space as well. For example, Windows 10 takes up, the 64 gigabit version of it takes up about 20 gigabytes. So productivity or work applications will also take up, for example, 3 gigabytes. Office 2016 takes up approximately 3 gigabytes. So there will be a certain amount of space needed for your operating system and for your applications. Optical drives, so your CDs or your DVDs, they're useful for playing back media. A lot of new laptops don't actually have them. They are sort of on the way out, though they're very portable, and some people still find them very useful. Ports or connections to your PC or laptop allow you to connect to external devices. USB 3 ports enable blazing fast transfer speeds with USB 3 devices. So again, it only works if you have a USB 3 device. HDMI ports let you watch things on the big screen. Most PCs and laptops will have a USB port, USB 2 or USB 3. And they look like that. USB 3.1 is the latest, and they look like that. Your HDMI port again allows you to connect, and you can see that there. SD can be useful for doing things like cameras or e-readers or tablets, and some use USB. And there can be a number of other ports. So again, if there's something specific you need to connect in, you need to make sure that whatever machine you buy has an appropriate port and enough appropriate ports for you. Software. Two main types of software. You've got operating systems and everything else is some form of application. So if it isn't an operating system, then it is an application. Within the college here, we use Windows. Windows is our main operating system. On your phone, you'll be using something like Android or the Mac operating system. And so, for example, applications within the college we use would be things like Microsoft Word or PowerPoint or Internet Explorer or Google Chrome, etc. All of those are applications that run within the operating system on the hardware. Operating system software. So again, let's just watch this video. Hit pause on this video now and watch the video of what operating systems are. So it's a series of programs that organise and control a computer, provides an interface so that the user can communicate with the computer, communicates between the software and the hardware devices. So without an operating system, you would have to physically connect to the screen and get it to produce an image. It's the software that allows you to type something on a keyboard, and the effect of typing something on the keyboard is that something appears on the screen, and it's the go-between between the two pieces of hardware. It organises the storage and retrieval of information, so it decides where to put files and how to find them again, and it manages the smooth running of programs in RAM and allocating the required resources. So it keeps RAM busy and fed with instructions and knows what's held in RAM and what's coming back from RAM. So it handles all of that. Popular operating systems. So Microsoft Windows, again, is the most commonly used operating system on computers. OS2, which is an IBM one, is not as popular anymore. The Mac operating system, again, a lot of people are very, very keen on the Mac operating system as it's considered very simple to use. MS-DOS is an old one, but again, often applications are compatible with it, especially in the hospitality industry. Linux is another alternative operating system that's an open source, which means it was developed by a community, it's free, there's no charge for using it, and it's popular as well. Unix, again, is another operating system that is used often by universities. So after this section, you should now know the different categories of computers and computing devices, the large units of measurements and how they apply to computer specifications, the basic units of storage, bits and bytes, and the grouping of bytes, what the CPU speed does and its values for computers, and the effect of multiple processing cores on speed. And other things that you should know: what is the function of RAM and how it works, and what are reasonable amounts to purchase when you're buying a computer now, the main types of storage devices, looking at the common ports and how many you need, and also the purpose and function of an operating